that says there is an AB member. It has a pin connection to BC member. Again, we have a pin connection at C and then A. Okay. And the length of AB is 3 meters. From B to D and then D to C is 2 meters. It has a load applied on D. And then the question is that find the reaction forces at A, reaction forces at C. So to solve the problem, we separate this frame into two members. Okay, we section it, and then here I should have, instead of C, it should be B, and then C should be, this one is B, and this one is C. Okay, and then for each portion we will write the forces acting on it, and this way we will simplify the problem. It looks like this one is very similar to method of sections, but let's first write which forces do we have at pin A and then pin C. For forces, I will say that we have a reaction force here, which is AY, and another reaction force here, which is AX. Similarly, for here we have CY, and then we have CX. And then B, you have to know that point B is an internal point. Okay. Here we cannot show any force on B. But if you section it, now we can show the forces on B. Here it is an internal point. It has equal and opposite forces. If I do this way, again I will have the force AY and then force A of X. Again here you will have the CX and then CY, and we have this 2000 Newton force. Okay, so now we have to find what is the force acting on B. So for equilibrium, the force at B should be equal to force at A, but opposite. Okay, and from this one I know that the force at A is this way. Okay, this one is the force at A, so there should be an equal and opposite force at B, so that this one is in equilibrium. So we will have a force at B. So we have one member with two forces. This is called two-force member. With two-force member, it is easier to analyze the structure. Okay, instead of writing the components, we just write the force here. Okay, then point B will have, again by Newton's third law, equal and opposite force. So it will be, let me use different color here again. Again it is FB, but this one is by Newton's third law again. Yeah. So as you can see, we have one unknown, two and three unknowns. But if you didn't write this way, we would have one unknown, two here, x unknown here, bx, by here, 4. Okay? But by simplifying it to two-force member, we have decreased the number of unknowns. So we have decreased the number of unknowns. Again, for this one, we will write the equilibrium equations for BC. The first one will be that the forces in x direction will be 0. Okay, and I will take this way as positive. There is a x component of FB, there is x component of C, and then we have 2000 newtons. So it will be that Bx minus Cx, sorry, it's positive, and that is 0. Okay, but I know that FB is this way, and we have 60 degrees here. So I know that this is FB. It has a 60 degrees. From here, this one is, let me put this one as, instead of Bx, I will put this one as FBx. Okay, FBx. That will be FB and then cosine 60. Cosine 60 is 1/2, that will be FB by 2. And then Cx is unknown. From here, what we get is that Cx is negative FB by 2. Okay, that's what we get from the first equilibrium equation. And then second equilibrium equation, let's do that. It will be the y direction forces adding up to 0. Okay. Now we will have FBy, which will be FB sine 60. Again, positive, plus Cy, which is positive, and then minus 2000, which is negative. Okay. So, and we said that this one is FB sine, so that will be FB times 0.866 plus Cy is 2000. Okay, that is for the y direction forces. As you can see here, so we have 3 unknowns, which is only FB, Cx, and Cy, but 2 equations. So it means that we need one more equation. So that equation will be the moment equation. Okay. For moment equation, you can take point B, we can take point C, or we can take point D, even we can take point outside the member. Okay. But the best here is that to take a point that will make the problem simple. So if I take this point, so we will have Cy creating moment, we will have Cx that doesn't create any moment because it passes through point B. Okay, so this one will make the problem easier. Or you can take this one. Again, Bx will not create any moment, but By will create moment. Again, the problem will be similarly solved. Okay, so taking B or C is the same. It doesn't matter. But if you take point D, so you say that you will have Cy as unknown, Cx doesn't create any moment, and then B by Y will be unknown. So this one is not good. So the B or C is good, but D is not good. Okay. So I will take point B. And then from here, it follows that about point B, 2000 newtons creates a clockwise moment with an arm of 2 meters. So it will be that 2000 times 2 with a clockwise moment negative. Then Cy will create a counterclockwise moment about B with an arm of 4 meters. Okay, that one is a counterclockwise moment. So from here, we just found that cy will be that 2000 times 2 by 4. So since we know the cy, from here we can replace and back here find FB, that is 1155 newtons. Okay, so we have FB, we have cy, and then time is to find Cx, which will be half of it, 577. So from here cy will be negative 577 newtons. Okay. So means cy is this way, Cx is, sorry, it should be Cx. It means the Cx is this way, cy is positive, FB is, it's the so FB is positive. Okay, so from here we can find the FA as well, which is equal and opposite to FB. Okay, so if you look for the magnitude, FA is same as the FB. Okay, so that will be 1155. So this one component will be, again, you will have 60 degrees here. Okay, so it follows that FA will be 1155 newtons. Okay, and then AX and AY components will be just the cosine of it and then sine of it. Okay, so with this one we finish this frame problem.